General idea what we're going to be doing.
Yes, for writing it out.
For writing it out. General idea. What we're going to be doing, gentlemen and lady, we will be going over calculating the service entrance equipment and conductors for an apartment building that has 30 units or apartments or flats, like the British will call them, and a bunch of loads. That I'm going to give you the loads over here, and we're going to follow these step by step. What I'm going to do today, different than what we did yesterday, I'm going to have one screen for every calculation. So to follow up with me, guys, do me a favor. What I'm going to do, I'm going to have one screen for every calculation, and later on leave yourself some space at the bottom, because I'm going to go back to the same screen and do the neutral calculation right where I did the amp calculation or the calculation for the phase conductors. So when I leave space at the bottom, please leave a space at the bottom, because I'm going to come back and do the neutral calculation.
So we're gonna have 3 pages, one of.
We're going to have, I'm going to try to have a 1 page for every item. So we're going to have 21 pages. We're going to end up with 21 pages based on these items that you have or so.
I'm gonna write.
Not for you guys, for me, but you can gauge yourself. You can gauge yourself. Okay, the page number 1, I'm going to put the criteria. What are we doing? What are we doing, right? The criteria number 1 is we're going to do general lighting. We'll do everything. Here's the assumption. Assumption number 1. We have an apartment building. Move yourself away from me, buddy. Okay, we have apartment building with the following assumption. Assumption number 1. Units. We have 30 units. Anybody has an issue with that? 30 units. Voltage system. Voltage that I'm feeding it is 208/120 3-phase system. 208 120 3-phase, well-respected voltage system in the industry. The second thing, every units has everyone, or unit, let's say unit has the following. So these are the assumptions. The following is in every unit. Number 1, we're going to have a range for every unit. Range, and that range is, I'm giving you 9 kW. Number 2, in the same unit, we have a dryer, and the dryer is 4.5 kW or kW. Number 3, I have a water heater, and this guy is 4 kW given. Number 4, I have dishwasher, and my dishwasher is given as 1.6 kVA. And number 5, I have a microwave, and my microwave is given 1.5 kVA. Number 6 is garbage disposal, and it's 1 kVA. Number 7, Number 5 is microwave 1.5 kVA. Microwave. 6 is garbage disposal. Okay. So listen.
You said you have a file online.
On the network.
Oh, what file is it under?
It's fall.
Yeah.
Under ECDM 211,
Okay.
211, and you should service calculation. So 7, we have a fan, and this fan is rated for 3/4 horsepower. You can call it this way. Bathroom fan. Bathroom fan. And 3/4 horsepower. 3/4 horsepower. Number eight. Number 8 is we have an elevator. Elevator. Oh, not for every apartment, the elevator. Very good point. Let's leave the elevator until well, let's put it here and say just for the building. We'll highlight it. Elevator 50 horsepower at 208 3-phase. Can you guys highlight this one? This is only one. Only one. Only one. Only one elevator. You're absolutely right.
What's number 6? What does it say?
Number 6 is garbage disposal. Garbage disposal. We have an elevator. Number 9, I have garage opener, door opener, and I have a 1 horsepower. 1 horsepower. Number 10, I have AC unit, 4.5 kVA. And last, number 11, last is heating system. Don't ask me what this heating system. It's 3.5 kVA. Okay? This is basically the apartment that we need to do the calculation for. Anybody has any issues with that? Other than 8, each one of them, each apartment has one of them. It'd be great if every apartment has its own elevator, huh? Other than 8, each apartment has one. So just highlight 8. Everybody got that one? Thank you. The units, I will write it right here. Thank you. Each unit, I'm putting it in a different color here, as 200 square foot, and I'll add another 0. 2,000 square foot 0. It's really good apartments. Each unit is 2,000 square foot. You guys have a problem with that? The people want to live their life here. What do you want it? 600 square foot?
300.
300? Do they make 300? Studio.
Let's give them 100.
Is it 300?
I don't know, it was pretty small.
Good grief. Okay, let's repeat the assumption. Number 1, I have an apartment building, meaning it's residential, dwelling, and I have 30 units, 30 apartments, 30 flats. The voltage system that I decided to feed this unit with is 208, 123 phase. Each unit is 2,000 square foot. Each unit has a range, a dryer, water heater, garbage disposal, microwave, dishwasher, fan, elevator for all the buildings. Garbage, garage opener, door opener, and a heating system, and a cooling system. Okay? Any question guys about assumption? Yes, sir.
We have lights.
The lights are the special lights. No, the lights are going to be part of the 3-volt amp. Yep. Are we cool?
You cover it.
And what do we need to do? Write yourself a note. We need to go size the service entrance equipment, service entrance disconnect means and overcome protection device, and service entrance conductors, equipment, conductor, overcome current protection device. And we also will do the electrode grounding conductor. and then I'll leave up to you guys to go do it for every unit. I'm going to do the whole building. When you do it for every unit, you just drop the things that does not exist in every unit. All right, any question?
Well,
Yes.
Are you gonna have us do every unit?
Optional.
We only have to do one, right?
Oh, you mean for our project? Or for this example? For this example, no. For our unit, for our project, you guys are doing calculation for the service and calculation for every unit. Move on, Chad. Mr. Rabab, I like your M here. Stand for Minnesota or what?
University of Minnesota.
University of Minnesota. Cool. All right, let's go ahead and start. And I want to start, guys, by following the steps that I gave you. First of all, we need to find general lighting. I'm going to use one color. Shall I use blue? Is blue good? Shall I use blue? I'm going to be using blue for the phase, and later on I'll use a different color for the neutral. Okay, number one. Okay, number one. Everybody knows what, by the way, I didn't write it down, but everybody knows what do we need to do for this apartment? Size, the service, entrance equipment, conductors, and overcome protection device. Should I write it down?
Yeah, it would be better.
That would be better.
In the bottom, right?
In the bottom right here, what do we need to do? Size, service, entrance, equipment. Number one, over current protection device and conductors. So we need to size the service entrance equipment, service entrance conductors, and service entrance over current protection device, or disconnect means. And thank you. And another and grounding electrode conductor. And grounding electrode conductor. Grounding electrode conductor. And conduit. Conduit, if you want to be so specific. Conduits. The conduits. So these are what we're going to be doing. We need to size the equipment, meaning the panel, the overcome protection device, that big fat thing that sits inside it, fuse or circuit breaker, the conductor that bringing the power to the panel, and the grounding electrode conductor that goes all the way to Mother Earth, and also the conduit that brings the conductors. Like we do all the time, guys. That's what we do as designers. When we size, what do we size? We size equipment, we size conductors, conduits, and we size grounding system. All right. Any question? Ben, my friend, the ride this morning was good?
I drove.
You drove? Okay. Now you
It was nice.
suffered a little bit.
I suffered.
Told you keep riding your bike, man. Wish I could do that.
It should be just start a new page and just go back to the journal even with those.
Yes, for you, start a new page. Yep, start a new page. Give yourself enough ample amount of time and effort. Okay, the first thing I need to do, guys, I need to find general lighting load. General lighting load. General lighting load, to find it, you need to go to table 220.12. All these numbers are, you guys have them, right, from the sheet. We're going to go to table 220.12 and also article 220.12. If you read through the article, it sends you to the table. Okay, since we are dealing with residential, it says we need to use a 3 volt amp. If you guys go to this table, multiplied by square foot of the building. What's the square foot of the building? 2,000, and multiply this by 30. Anybody knows why?
30.
30 units, 2,000 square foot, 3 volt amp. Where did they get the 3 volt amp? From the table.
There's no common area.
Are you, for the whole building, why don't we take into account the whole building?
This is already included. Let's assume that already included.
Okay, but normally, if you're just giving us square foot of the dwelling.
You're absolutely. If you're doing the square, if you're giving a square foot of the building, they will give you a square foot of the hallways or the common areas too. But let's assume the 2,000 square foot, guys, is actually the common areas included in them.
180,000.
Okay, I want to work in KWs and KVAs today. Not, I want the answer to be always in kWs and kVAs. So I'm gonna divide this one by what? 1,000. You guys have issues working with kVAs? We know we can work kVAs or voltaire. What's the answer?
180.
180 kVA. 180 kVA. Okay? 180 kVA. Any questions about this step? Straightforward? Alright. I'm going to go to a different page. I'm going to give myself ample amount of time. Give yourself time, this base here, guys, because I'm going to come back and do the neutral calculation right underneath it. So give yourself maybe 6 lines so you can do the neutral calculation right in here. Okay? So I'm going to go to the next step. Step number 2. I don't want to do step number 2, guys, for our calculation based on this sheet. I'm going to jump directly to step, because step number 2 has nothing to do with the load calculation that we do. I want to go all the way. I'm going to do that without confusing you. I'm going to go to 3. I'm just going to skip 2. I skipped 2. Everybody knows why I skipped 2 based on the sheet that you have. Because 2 has nothing to do with the load calculations, just finding the branch circuits. I don't care about the branch circuits at this time. Everybody knows why I skipped 2. And I don't want to renumber them just because I want to follow up with the format that we have. Okay, what does 3 say? Small appliances branch circuits. Small appliances branch circuits. And to find this, you need to go to 220.52a. All right. Small appliances, 220.52a. Now let's say if every apartment is going to have how many minimum?
2.
Every apartment, if you guys go to this article, is going to go 2. Let's use the calculation with a different color. I'm going to continue with the same format that we did. Black, blue. Small appliances branch circuit. And the article is 220.52. Okay? And then I'm going to do my calculations. So 2. Anybody knows why 2? 2 for every apartment multiplied by each apartment is 1,500 multiplied by how many apartments do we have? 30, and I divide by 1,000. Why divide by 1,000? Because I decided to do everything in kVA. You don't have to divide by 1,000. It's great, guys, when you have when the load becomes big. Work with kVAs.
Oh, sorry.
Yes, sir.
The 1,500.
The 1,500 is from 220.52.
Oh, but yeah.
52 and an A. Thank you. And an A next to it.
90.
I need that 2 gentlemen or gentleman and lady. 90 kVA. Great. Step number 3. Any question, guys, about that? 90 kVA? Any question? 90 kVA? Ben? No? I'm gonna give you a pen here, pencil.
Yes.
Here, man, you want a pen?
Oh, yeah, I just want to mess. If I mess up, I like to.
Well, here's the next one.
Oh, there you
Here, I know
Oh, these are
mechanical
markers.
pencil.
Mechanical pencil?
I'll use
Here,
that.
go. I
great.
just didn't sharpen it. I did.
That's all right.
Thanks,
Keep
guys.
sharpening.
Yeah.
Oh, man, we're generous. Okay.
It's done.
Number 3. Number 4. Number 4. Number 4. What does number 4 say, guys?
Laundry.
Laundry. I have laundry.
Are we gonna need to leave a spot for a neutral?
Oh, yeah, always leave a spot for the neutral, guys. For it, all of them. Laundry branch circuit. Laundry branch circuit. We have 1 for each. Oops, I'm going to use a blue again, the same format. I'm going to have 1 for each multiplied by
What section?
1,500. Yep, thank you. What section? Very good. 220.52. 220.52B. Okay? And then I have 1 multiplied by how many units do I have? 30 divided by 1,000. Everybody knows by 1,000. What do you get?
45.
45K? 45K VA. Anybody disagree? Dare to disagree with Ben? No? Everybody's okay? 45? Good, thank you, Ben. Okay? I'm going to go to step number 5. Step number 5. Number 5 is math. Add 1, 3, and 4. So I want you guys now to give me number 1. How much number 1 was?
1 is 180.
180.
2 is 90.
K plus 90 plus
45.
what?
45.
45. What's the answer?
315.
315 kVA. 315 kVA.
45.
45. Did you write the 9? 45. Thank you, Mr. Rivera. 180 plus 90 plus 45 equals 350, right? Okay. Just because there's nothing here, I'm going to add, we're not going to be doing calculation here, so I'm going to go to 6 now, right here, guys. And demand, applying demand factor. Applying demand factor, you have to go to table and article, table 220.42. If you go to article 220.42, here's how we're going to go to the table, guys. I want you to go to the table. Now this is interesting because we're going to go to the table, which is 220.42. Thank you, my friend. Okay, so what happened when 220.42. Everybody's at 220.42. If you guys look at the 220.42, here's how we're going to start. I'm going to start by 315. The first 3K, leave him alone. The first 3K, leave him alone. First 3K, leave him alone. Okay? And I want you to wake up here with Chad. Anything after that, and I'm going to write it in a different color. After that, anything all the way up to 120, you're going to cut it by what? 35. So listen to me carefully. I have 120. I already took 3K, left him alone. What's left over after 120? 117. Did you guys hear me? Up to 120, you cut by 35. So I have up to, forget about the first number. Up to 120 cut by 0.35. So you have 120, you took 3 from it, that left you with what? 117. So I want to take 120 K, these are all K's, guys. K minus 3K, that will give me what? That will give me always. And I'm going to use this one, guys, in red because this minus 3K equal 117K. Let's just do that one equal 117K. This one you need to multiply by point, what is it, 35? 35. Okay? Well, let's use the same format like the arrow to go to. All right. Why 120? Because it says your limit is 120. The next one always changes. You're going to take the 315 minus 120. What would that give you? 315 minus 120. 195. Multiply this one by 0.25 and add them up. Let me repeat myself one more time. The first 3K, leave them alone. All the way up to 120. After you took the 3K, cut them by 35. So here's a hint for you, Chanel, my friend. A hint. See that red stuff? That red calculation? That red calculation here? It always stays the same if your load is higher than 120. If your load is higher than 120, this calculation red always stays the same. Always. Did you guys hear me? If your load is higher than 120, your calculation here always stays the same. Because you always take 120 minus 3 and multiply it by. If you're less than 120, then you don't need to go to this step anyway. You don't go to the third step anyway. Okay. I need a gentleman and a lady.
Where do you get the 25%?
The 25% from the table.
Remainder, okay.
125. Okay, can you use on the man? I need just looking at. Oh, you guys want coffee or something here? Okay, I need. What's the answer? Everybody knows what we're doing here. We're adding them all together. 92.7 kVA. This is the number that I'm going to highlight because I want to carry. I want to highlight this number because that's my demand.
Shared around that just for the sake of.
You can, yeah, you can.
Are you adding both numbers? That's why you're gonna improve.
I am adding the 3 to the 117 times 0.35 to the 195 times 0.25. Arithmetics.
I get that. I mean, I'm not getting the same number you are.
Oh,
117 times 0.35 is 40.55.
Yeah. I got that.
195 times 0.25 is 48.75.
Huh, let me re-add it. So I got the same numbers.
let me get some coffee while you were adding.
And then I have,
Oh, plus the 3.
9.7.
You have to add the 3.
You're coming with a different number?
No, I got it. I wasn't
Okay.
adding the 3.
All right. Okay, good. We're all in agreement. Good. Doesn't happen in politics that much. Okay, let's go now to step. Which step are we doing, buddies? We're going to go to step. What comes after 6? It comes 7. Step number 7. Step number 7, ranges. And everybody knows when I say ranges, I don't mean gas ranges. I mean electric ranges. Okay, for ranges, we need to go to table 220.55. Table 220.55. Let's see what we have first. Can you guys go? We have ranges, all of them are 9. For ranges all the same size under C, guys. So they have to be under column C. They're all 9. How many of them do I have? 30 of them. I have 30 of them, right? Why 30 ranges? Let's see what we have. We have 9 kW. And how many of them do I have? 30 ranges. Right? Why 30? Because one for every apartment. So this will put me under C. Everybody look at the table under C. This is table 220.55 under C. It says over, so if they're all the same size, and their maximum demand kW not over 12, so your demand, you just look directly under C. Directly under C. You don't have to do, they're all the same size. They are more than 8 3/4 and less than 12, right? And they sit directly under C. So I'm going to go under C. You guys have used this table right before, so we're not So we're gonna go to, how many of them do I have? I have 30. I have 30 of them, right? Okay, let's go to the table. So I'm gonna take 30 units, 30 units, not units, 30 ranges. I'm gonna take it to table 220.55 under column C. If you guys look at under column C for 30, it says 115K plus 1 kVA for every range. So 115K plus 1K for every range. How many ranges do I have? 30. So that will get you a demand of what? 45 kW or kVA, the same in this application. Everybody saw what we did? They're all 9, they're all under C. So what the code says is when they're all under C, all what you have to do is find how many of them do you have, and the demand under C is always in kW. C, guys, is always confusing to A and B. A and B are given in percentages. C is always given in kW. Anybody disagree?
That's 15, okay?
That's a 15K plus 1 times 30. Everything is K, of course. We're K. And I want you to highlight this. That's my demand from this step. My demand from the ranges. Ranges demand. Any question about that? Camille, my friend. Cool. Move on. Slow down. Step number 7. What comes after step number 7, DJ? Thank you. I thought one of us is awake. Okay.
Electric dryer.
Electric dryer. Let's go to electric dryer. Thank you.
Leave a spot for neutral there.
Yeah, leave a spot for neutral. Thank you. Number 8, dryer. I leave the word electric because you guys know dryer. Okay. Dryers.
220.54.
For my dryers, we're gonna go to 220. Thank you. 220. 220.54 or 3. Table and article. 220.54. And for these boys, how many dryers do I have? 30. Okay, let's go find the demand. First of all, what's the kVA of the dryers I gave you guys? Huh? 4.5. The code says if the dryer is less than 5, what do? You go to 5. So first of all, let's go find. I have 4.5K. The code says this have to transfer directly to 5K because less than 5, you use 5. That's number 1. Number 2, let's find the derating factor. How many of them? I have 30 dryers. The rating factor from table 220.54 for 30. Let's find for 30. Let's do this some math to be done here. For 30. 30 is between 24 and 42. It says 35 minus 0.5. So here's what it says. 35%. Okay, great. Minus what? Minus a 0.5 for each dryer exceeding 23. Okay, so minus 0.5. Open the brackets here. How many dryers do I have? 30 minus 23. That's what they're telling you. Anything higher than 23, cut it by 0.5 and subtract it from the 35. Talk about fuzzy math, huh?
I have a question.
Yeah.
This is a 3-phase though?
These are 3-phase.
Single-phase dryers on 3-phase?
These are running 208. They're not 3-phase dryers. We're running them at 208.
So it's calculated totally different than if you have single phase on a 3-phase, it's twice the maximum load connected to the phase.
This table is for dryer with 2 or more
If you
single
look
phase
on
ranges.
220.54,
220.
2 or more single phase dryers applied by a 3-phase feeder service, the total electrical load should be based on twice the maximum or connected to between any 2 phases.
We're balancing them though. We're balancing our loads. The way we're going to do this dryer, guys, we're taking 208 and we're putting dryer number 1, 208 in phase A and B, then phase B and C, and phase C and A. So
Unless there'd be 10 in each phase, so it would be twice.
How many do we have? We have 30 divided by 3, that will give you 10 on every phase. They're balanced, right? 10 on every phase, or between two phases, 10 between two phases, that will,
Yeah,
that will
so then
get
you
you
take
down.
twice the maximum between two phases.
And you
If you have a
size them.
single phase dryer on the three phase.
Where's that again? Let me-
2054.
Single phase dryer
Two-
supplied by a three-phase four-wire feeder, the total shall be calculated.
Where 2 or more single-phase dryers are supplied by 3-phase 4-wire feeders, the total load shall be calculated on the basis of twice the maximum number connected between any two phases. On the basis of twice the maximum number connected between any two phases.
So 10 is the maximum.
10 is the
So you take
maximum.
twice.
That will give it twice of 10.
So you just 20 is your math, I see.
Shall be permitted.
And then
Okay.
you,
Where 2 or more single-phase dryers are supplied by, okay, the total shall be calculated on the basis of twice the maximum number connected between any two phases. Let's just do this calculation, guys, and then we'll get to that one. So what's the 0.5 times 30 minus 23? So that'll give me 35 minus 0.5 times, what's the answer for this? 23, give me 7, right? And then 35, don't forget the percentage, minus 0.7 times 2 is 3.5. And what would that give you? 35 minus.
35% of what?
What? We're just trying to find, right now, we're trying to find the percentage, and then we'll do the calculation. I'm just trying to find the percentage, guys. All this calculation is just to find the percentage. So what is 35 minus 31.5? That would be 31.5%. 31.5%. Okay, 31.5%.
What did you do there?
Okay,
35 minus 0.5.
35
30
minus
Okay.
30 minus 0.5 multiplied by 30 minus 23, because that's anything higher than 23, you cut it by half and you add it. So my demand is 31.5 had this been a single phase system. Had this been a single phase system. Had this been a single phase system. Maybe we shot ourselves in the legs by adding a three-phase system.
What is that 35 minus 3.5?
35,
The next one.
35 minus 3.5 percentage.
Oh,
Minus 0.5% for each dryer exceeding 23. So we have 7 that are more than 23.
Did we do the math right on this at least?
Even though that's not how I read it.
The math is right. You're right on that one. So had this been, I really want to do this example because
You know what, that pertains to ranges too.
yeah, ranges too, the same calculation. Yeah, you know what, guys, just to be consistent, because I really want to use these derivative factors. To be consistent, let's just go back and do one little change. Let's convert our system into single phase 12240 system. That's all what we do. And then everything continues the same. Can you guys do back? Let me go back. I really want to do the calculation here. Thank you for,
I
no.
just remember because I struggled with that one.
Okay, I'm gonna go. I just want to do one change here, just to put because I really want to do I want to the example here, guys, is just to get you to use the table. Okay, and then when we get into three-phase system, we get into a lot of other stuff. Let's just go change this system. Nothing other than just changing this one into 240/120 single phase. Everybody got that one? Everything continues the same.
You gotta do the elevator too.
The elevator, yep, the elevator is going to be my elevator. I need to change the elevator. You're not going to find that 240 motor that big. So I'm going to change my elevator to 240 single phase. Thank you. And let's change this one to the highest motor that you can get single phase. I believe it's 10. Change this one to 10. Okay. These are the only thing. And let's continue with single phase. I'm not messing around with the three phase. Very good point. Everybody's okay? Did you guys do this correction? What correction? Perfect. Then we can continue with. I really want to use because the idea is to use the table. I don't want to jump into. We can switch it, but I just want to use the table. Okay, 24120 single phase, perfect. Everybody got that one? Everybody got it? Good. Let's go back again. Then all my calculation is perfect now. See, all what you have to do is just change the assumption.
Can you explain where you got that? I don't know if you got that.
Got what?
5 from.
35. Look at the table. 220.54. It says between 24 and 42. Between 24 and 50.
Oh. Okay, all right, okay.
Any question as the first start with 35, then anything higher than 23, cut it by half and subtract it from the 35%. Fuzzy math. Okay, so that's just to find the rating factor. Just to find the rating factor. Then to do the calculation, you take the 5K, multiply it by how many units do we have? 30 units, multiply it by what's the percentage here? 0.315, right? Everybody knows how this 0.315 is actually 35.5%. And then this is my calculation. Then that will get you the rating factor. Anybody has a 47, anything 0.25, 0.25, 0.3. KVA. This is what we're going to be carrying out from this step. Okay. Everybody's there, my friends? 55.
Hmm?
47. If we use the guys, if we use the three phase, if you use the three phase and between two phases, that will divide them. That will be 10 times 10, 20. That'll get you a much lower value than that, right? Had this been a three phase system, you end up with 20 the demand versus 47.3 kVA, right? Because you divide them between the phases, 30 of them divide by 3, that'll get you 10 between each two phases, multiply by 2, that'll get you 20 kVA. And the same thing for the ranges. The range is the same thing, guys, because that's why I don't want to go back and change the ranges. Where the two or more single phase ranges supplied, blah, blah, the total shall be calculated based on the twice the maximum number connected between end two phases. So we have how many ranges do we have? 30 ranges. Divide the 30 by 3 because 3 phases. That will get you 10 ranges. Each range is 9K. 9 times 10 ranges. So then based on, that will get us, shall be calculated on the basis twice the maximum number connected between the two phases. Hey, how you bud? Look at you sharp.
Yeah.
Give me 1 second, guys. Let me get.
Do you want to reach pause it?
1 second.
Oh, you still do? Mr. Boo.
All right. Sorry for that. All right, let's just continue with this. We'll take an example about three phase, guys, when we get into three phase. So we got this step. Let's go to step number Number 8, step number 9. Do we have heat and cool system? Heating cooling system. 9. Heating, cooling. Cooling system. Heating and cooling system. This is non-coincidental load. 220.60. 220.60. Heating and cooling system. How many, and you take it at 100%, no derating. So what's the AC? Let's start with the AC. What was the AC for the AC, the cooling? Let's use the cooling. Cooling. For the cooling, guys, what was the AC? I gave you guys a size for the AC? 4.5. 4.5K. Multiply this by how many units? 30 units. And then for the heating, heating is 3.5. Multiply this by 30 units. So can you guys give me the answer for the first one and the second one?
135 for the first one.
135K. The second one? 105K. And you have to choose the largest. You're going to choose the largest. Which one the largest? Obviously 135. There you go. We're going to carry it. This is the largest of this step. So you pick the largest between the heating and the cooling system.
You don't have to do any derating.
No derating. No derating. At 100%, no derating. What's left? We have, you caught us with that 3-phase, huh? That's
I
good.
remember that one. 'Cause
I really
used to
forgot
always
it.
get it wrong. It's like,
I was thinking of I want to use the tables to explain it because I want, they're not jumping into whole different things. We'll get an example of what that one. I want to switch track here, guys. And just to keep us on track, I'm going to call this step, can I move? I'm going to call a new step. I'm going to make a new step for motors because motors, we don't have, based on my sheet, I don't have a step for motors yet. Number 14. Well, you know what? Let's follow this track. Just to follow it. Let's follow the way we did it. Number 10. Just add them all up. Okay. Electric furnace. We did the electric furnace heat and air conditioning, all that stuff. Let's do number 10. I'm going to do it to a different page. And do number 10. Number 10. I'm going to add. Which steps? 220 to 51. We're going to add
7, 8, 9.
6. I thought 6, 7, 8, and 9. Add 6, 7, 8, and 9. Just doing math. And I need a gentleman or a lady to give me 6, 7, 8, and 9, please. What was the value for the 6?
92.7.
92.7 plus.
45.
K, these are K's. Plus 47.3 K plus
135,
135 K equal
320.
320 kVA. Anybody disagree? Adding all the steps that we did. Did you guys come up with 320? Anybody can? Okay. So we add them up. All right, I'm gonna go. I'll do the fasting in place and then I'll give you a few minutes break here. All right.
Oh, come on, we can carry it out before break.
11.
We need to save room for neutral.
Fasten in place. Equipment. And this is 220.53, right? 220.53. Verify that one, guys. Article 220.53. Let's see what do we have fasten in place equipment. Let's look at the fasten in place equipment. Dryer, excluding the dryer, so I have water here. Let's do the calculation here. These are fasten in place equipment. I have my water heater at 4 kW, dishwasher at 1.6 k VA or kW, microwave at 1.5 k VA, garbage disposal at 1 kVA, 1.0 kVA. Fan no, garage door no, motors. Did I miss anything? Can you guys look at them? I have this one, microwave. I have dishwasher, garbage disposal, elevator no, garage door opener no, HVAC. We already did the HVAC. We already did the dryer and the range. The leftover is just motors fluid. Okay. So how many of them do I have?
4.
Wrong. Each one is going to have 1. So this is multiplied by what? 30 multiplied by what? 30 multiplied by what? 30 multiplied by what? 30. So I have 30 plus 30, 60, 120. So does the rule apply to them then? 120 equipments, right? All together. 120 equipment. Can you guys do the math on all of them and give me, add them, basically multiply them and add them up. Multiply and add up all of them. 243 kVA. I need somebody to verify because I trust but verify. Is that what Reagan said? Trust but verify. Need another lady or gentleman to tell me that what my friend is doing.
Yep, I'm sorry.
243. There's another gentleman. Now good. What else do you need other than 2 gentlemen? Step number 12. Demand. Demand for fasten in place. For fasten in place, guys, the demand factor from 220.53 is what? 75. So you take the 243 and multiply it by 0.75, and that will get you a healthy 182.25.3. Okay. The first we added them up, and the second we applied the demand factor. Now we can do you can do 11 and 12 in one step, guys, since we have the steps like I did yesterday. But now since we have the steps, might as well use them. Break time. Let's take a 5 minutes break. Thank you. Okay. Let's we have the demand, guys, for the fastened in place appliances. This is step number 12. Let's go ahead and do step number 13. Step number 13. Step number 13.
Well, I know my whole.
Step number 13, guys.
Do we want to put the demand factor?
Total computed load. Step number 13, we're going to add 10 and 12. Add 10 and 12. Right? We're going to add 10 and 12. So what was the step for 10?
And then 12 is 182.31.
Okay, 10.
10 is 320.
320 plus 12.
182.3.
182.3. Okay. We're going to add these two steps, right? Because 10 is already adding everything basically. So we're gonna add 10 and I'm sorry, 10 and are we on step 13 computed load? Yeah, 10 and 12. Yep. Because it demanded. What's the answer, guys? 500 and 502.3 kVA. Okay. This is step number 13. Almost there. Hang in there. Step number 13. I want to do step number 14 here because step number 14. Well, no, I'm going to actually do step number 14 different location because I need more. Okay, you got that? Step number 14. Number 14 is motors. Motors, guys, are, for all motors, we're going to go 220.50, 220.50, and also you can go to Article 430. If you go there, it will tell you, take the largest motor, multiply it by 1.25, and add all the other motors to it. Let's see what type of motors do we have. Start with the largest to the smallest. Brad, we have a elevator. What was the horsepower in there? 10 horsepower at 240. So I need to go convert this one from 240 dot I'm sorry, 430.248 table. What's the full load amp? Under 230 volt. What's the full load amp of this the elevator? 50. So you're gonna have 50 multiplied by 240 and get me the answer for this, will you? That's converting the horsepower into volt amps. 50. Anybody disagree with Brooks? No. Brooks? In KVA. Don't forget to divide. We're doing things in KVA. 12 kVA. Okay, so that's just Mr. Elevator. What else do I have? I have a fan. My fan, what was the fan? 3/4 horsepower and at 120 volt. Take it to the same table, guys. What's the full load current? 3.6 times 120.
Wait, no, that's not right. 3/4, 6.9.
For 3/4 under 120, 6.9.
13.8.
13.8 times 120 times the voltage. Are you guys, everybody knows what we're doing? We're converting horsepower into 120. We're converting horsepower into what? To volt amp. Divide by 1,000 always. What do you get?
0.45.
How much?
0.45.
0.45?
Yeah.
Okay, 0.45.
Yeah.
1.7. 1.7 kVA. All right. Yeah, no problem. So we're converting the horsepower into what? Into watts, right? We're converting horsepower into watts. What was the last one? We have another horsepower. Garage door opener. I'll wait.
Can you just go back to 13 quick?
He's
After
that's
this,
what you do what?
I just, so I added 10 and 12 together. I didn't get what you guys got. I got something like 520.
So we added them together. 502.3.
Oh, I did get the right thing. Never mind.
Okay. All right. Then the last one, guys, the last motor that we have is garage door opener, and that was 1 horsepower at 120. and I need to take this to the same table. What's the full load current? 16 multiplied by 120. And don't forget to divide it by 1,000. Always we're working with 1,000. How much?
1.9.
4.9 K. 1. 1.9 kVA. Everybody got that one, guys? 1.9 kVA. The last step.
Where are you getting that stuff from, the 16?
Everything is coming from 430.248.
240.
Don't forget that these are under 120 here, and this was under 120. The same table. 430.248, 240, 430.248. Okay. All right. What's then? I'm just gonna see how did we do it in one step. We're gonna do it all in one step. The full load current. 60 minimum. Let's do. No, we're gonna find the step. So I'm gonna take 1.25 times what's the largest motor that I have? 10, which is 12, plus all the other motors. 1.7 plus 1.9, and that will be the demand for this load. What's the demand? 18.6 kVA. The demand for this step.
Yeah, but are we forgetting all the apartment units with the fan and garage doors?
Everything it says the same. You're absolutely right. We have 30 of each. So we're going to take the first one, 1.25 times the largest motor. What's the largest motor? 12 plus. Now, if you take the largest motor out of 12, that leave you from 30, leave you with what? 29. That will be 29 times 12 plus 30.
We only have one elevator.
Oh yeah, thank you. The elevator is Oh, dear. That stays the same. Then we have 30 times the first one, which 1.7 plus 30 times 1.9. Thank you. Okay. Yeah, we forgot the 30 of them. We have one elevator. Spencer, did you drink coffee today? You're awake, man. Yeah, it's hard to get engaged into the motor calculation. Forget the 30. What's the size, guys? How much?
123.
123 kVA. Don't forget that everything is going to be divided by 1,000. Don't you guys forget that we're dividing everything by 1,000, right? Moving from K to non-K is a second nature for you. No? You come up with something different? Yeah. I'm going to use 14, but just to continue. 14.1. Do I have other loads? Other loads? One second. Do I have other loads, guys, left? Do I have any other loads? So this is none. None here. We don't have other loads under 14.1. Yes, sir.
I see you have 10 key, 2.5, 1.25.
Give
Because you have two pieces of equipment who are different. One piece is 1.7 kVA, the other piece is 1.9. So you have to multiply the first piece by 30 because there's 30 of the first piece, 30 of the second piece.
30 units.
Units. many emails we're getting?
He has a block now. I get a blocker.
Okay, we're cool, Mr. Bab? Because we have 30 units. All right, cool. I'm gonna add one step, guys. I'm gonna call this one 14.2 to add them all up.
31, there's no.
This is 14.1. There is no other. Let me just highlight 14.1. Was it?
Call it 15, 'cause there's no step 15.
There's no step 15. Thank you, buddy. Yeah, let's do 15. This is a new step. 15. 15, we're gonna add up.
13 and 14.
Yep.
And 14.
15. Add 13
14.
and 14, right?
Plus 14 1.
14.1, not 2. 14.1.
No, 14 and 14 1. That should get us through the other game.
What's the step? What's the step that we?
14 is other loads, and we don't have any. You would add those if
14 and 14 1.
Okay, add if any. Yeah, 13, 14, and 14.1. Okay, yeah, I see what you included. We don't have nothing. Can you guys give me these values, please?
502.3,
1 second. 502.3 plus 123 plus 0. Yeah, the last step is 0, right? Just to kind of accommodate it. Total
625.3.
625.3 kVA. This is my complete beautiful total. You guys don't like beautiful total? Okay. Any question about this? This is my load, my final load. I'm gonna jump and go ahead do two things. Number. I'm gonna use directly. Go here, guys. Remind me for this number 625.3, and I'm going to go to the next page. I want to use 16. I want to do step 16, and at the same time, guys, step 18. Step 16 and 18 together. Group them together. These two steps very related. Can you guys see these two steps? 16 and 18. Okay. Now, what was it? The total?
625.3.
625.3 kVA. I need to find the amps. If you guys look at this, I need ungrounded conductor. I need, this is on ground. Use ungrounded conductor. Grounded conductor. Or service entrance conductors. Service entrance conductors. Ungrounded conductors, 18. And minimum ambiguity for ungrounded conductor. Service entrance. Remember, this is a service entrance conductor. Same. So when we divide this one by, what do you think the voltage is? We changed it, 240, just to make it match what we do. What's the amps? Remember, there's a K. What's the amp? How much? I want it in amps. In amp. How much?
2.6 kilowatts.
2600 amp, 2600 amp, right? I want it in amps, guys, because we're going to go size the panel. We switch to amps, right? 2.6 K is 2600, right? 2600 amp, even. Okay, 2600 amp even. I'm gonna. Okay, right here, I want you guys to do the following. I want to size overcurrent protection device. Overcurrent protection device. overcap protection device, you take the 2600 to where? 240.6. What's the second overcap protection device? Next overcap protection device. How much? Wow, that's a jump. 3000 amp. Unless you guys have an adjustable circuit breaker, you're gonna stick with a 3000.
Would it be worth it?
Yes, in a case like this, I will buy an adjustable circuit breaker, will tweak it all the way to 26. But we have a fixed circuit breaker, and we're gonna size our circuit breaker at 3000 amp. Okay, let's go back again. This is the overcap protection device. How about the panel? And that will be service entrance equipment. Service entrance equipment, or the panel. What's the panel size? You guys have DeWalt? Take the 23, take 2600 amp DeWalt. Which page the panels to? 312. 3-12. What would you get? In a single phase. There's no single, you have single phase panels. If you don't, you just switch gear in the second page. 312. If you guys go to the second page, we'll make it 313 this time, because we're moving to a switch gear, switchboard, 313. And on the right hand side, there's single phase and three phase switchboards and switch gears. That will give me a 3000 amp. So great. Does my overcap protection device match my panel? Yes. Here's the situation. Let me tell you, what if your panel was 4000 and your overcap protection device was 3000? Is that okay? The overcap protection device have to be equal to the panel or smaller, not larger. So these have to be the same, or the overcap protection device have to be smaller. So if this was a 4000 amp, because I can't find a 3000 amp panel, then the circuit breaker will be 3000, no problem. A 4000 amp switch gear, broken or protected by a 3000 amp overcap protection device, that's cool, no problem. Okay, so we found this. Then we need to size the service entrance conductors. Service entrance conductors. Here's my question for you guys. Would you go and size based on the 26, or would you size based on the 3000? Remember, up to 800 we size based on the amp, the load. Higher than 800 you start matching the overcap protection device to the conductor to the overcap protection device. So we have to size based on the 3000. Now we drop that 2600. We can't use the 2600 because this rules now.
What did you say that? What was that? How did that work? You just said up to how much?
Up to 800 amp. You can your overcap protection device can be slightly larger than your conductor amp. Okay, so I have 3000. I'm gonna go, guys, and parallel 10. Why 10? Because 10 will give me 300, and 300 will be around a nice number. Can I parallel 12? Bring it on. So I'm gonna go parallel 10. That will get me 300 amp. Take this one to 2. Where do we size conductors? Take it to 310.16 under 75-degree column. What do you get? How many sets? 10 sets. 10 sets of how many conductors? 10 sets, how many conductors? We're sizing the HOTS yet. So 2 conductors, 2 sets of 2 conductors. Number, what's the size for 300? 300? 350. 350 K, C, and M. Okay, buddies, here's your size. 10 sets of 2 conductors, each one of them is 300 kcm. Let's go find the neutral, and then we'll size the rest.
Did you just pull 10 just as an arbitrary number out of the air?
10 will give you enough. Well, when you parallel, you want to be around the 500 or less. Around 500. I always say 500 or less. So if you parallel another set, you don't want to be too small or too, so stay within, yeah, stay around the 500. So why did I pick 10, guys? First 10 is give me a 350. 350 is a really good cable to work with. It's less than 500. If you divide by 12, what would that give you? Probably 250. You can use 12. So the idea with paralleling, guys, is the least amount of paralleling is the best. So try to parallel. How about if we parallel 12? What you get if you parallel 12? That might be even a better option. Parallel 12. 250. How about if we parallel 8? 28, will ya?
375.
375? 375. So what's 500?
Why not by 6?
Then you get a bigger conductor. You don't want to go higher than 500. Huh?
3,000 divided by 6 would be
500. The conductor, that's 900, I think. Conductor size for 500 is what? Is it 900? That's big to work with. Unless you terminate it yourself, I'm not terminating that sucker. Okay, any question? So the idea is to stay around, guys, the 500 or there. Around the 500 on the less side. Does that make sense? And you minimum, remember, the minimum is 1 knot. You can't go lower than 1 knot. You're between 1 knot and 500. That's how I like it. Why I prefer. Okay, before we go ahead, I want to go, guys, back. We're going to do the neutral. We're going to go back on these steps and do the neutral, step by step, in a different color. And I want you guys to follow with me the same steps that we did. We're going to do the neutral. So we size our hots. We're going to do size our neutral. Go back. Sounds like a chicken here. Okay. General lighting for the neutral stays the same. Nothing here. No change here. We're going to go all the way to the demand. All the way to the demand. Where did we get the demand? Right here. See that number? Step number 6. Step number 6 for the neutral. Apply demand factor. Neutral conductors. Unit number, step number 6, guys. Step number 6. I'm going to use which color? Which color should we use for the neutral? Green. Green. Shall we use green? So neutral. Neutral. This one will stay the same. 97 point. This 92.7 kVA. Okay, so this is step 1, stays the same. Neutral stays right here. The same amount, no derating, nothing. Why? Very good. Why? Because if you add the lighting system and the receptacle system is what? Single phase. It's 120. So if it's single phase, then the current will go right directly through the neutral. Could go right directly through a neutral. That's why.
Is there a situation where we have to do it?
Is it a situation?
Is there a situation where you have to do it?
No. Derate this lighting more. We already derating here. No. But why do I use it? Because this, guys, is 120 receptacles and 120 lights. They count when it comes to the neutral. Okay? I want to go to step. I want somebody to keep track of this. So when we add them up. So we go step number 6. We're going to go step number 7. For step number 7, guys, step number 7, neutral. Step number 7, neutral. What was the article that I gave you for the neutral, guys? No, for the neutral was 220.61 A and B. A and B. If you guys go there, it will tell you you need to take the demand. What's my demand? The 47. The 47. Where did they get the 7? The 45 and multiply it by 0.7. the 45 and multiply by 0.7. Where do you get this? From 220.61. Okay, who's my calculator for the day? Who's gonna get 9.5 out of 10? Start going up. How much? 31.5 kVA. Highlight this, we're gonna carry it down. So this is all for my neutral calculation. My neutral calculation. Okay? So that's step number 7. We're gonna go to step number, what comes after 7? Step number 8. Are you guys done with the 7? Well, you didn't ask me if I'm counting down or up.
Vector.
Smart Alex Chan, huh? All right, let's go to 8. Mr. Bab. One. Okay, number 8. Number 8. Oh, now we use neutral here. Can I use red in this one with you, because I'm using, I use the green here. I would use red. Do you guys mind? So if you use neutral, for neutral, the same thing, 220.61 A and B. If you guys look at this, it will tell you that the demand 47.3, multiply it again by 0.7. Demand, cut it more. What would that give you? And that will give me my neutral calculation. How much? 33 kVA. And kVA. Okay, but you guys see how we went back and we just pick certain loads. Dryer. So how many loads? We have 3 loads so far. It's not lunchtime yet. Don't want to lose you guys. Not lunchtime. Okay, let's do next. Heating and cooling.
What number? 9? Always at 9.
Heating and cooling. Neutral as what? Big fat 0. Right? This step, the neutral here is big fat 0. Don't even look at it. Because these are connected 240. They don't contribute to the neutral. They shouldn't. So 9 is heating, cooling, big fat 0. Okay.
Aren't your clothes dryers running at 240?
Clo-
Your heating elements are running at 240.
Good point. The code does not want you to calculate it, basically. Good point. It's not substantial compared to the dryer value. You know, I mean, if you look at the majority of the load, that's my smart Alec interpretation, is the majority of the load as 240. The majority of the load in a dryer is 240. So there's no demand for, they don't want you to demand it. They don't want you to add it. No, we're not adding anything for the heating. Which step was that? Okay. Step 7, step 8, neutral. Is that what we did?
Yeah, we just did it for the dryer, but those are on for the, yeah.
You confused me.
The ranges are 240?
Yeah, 241.20. Ranges is 241.20. Dryers are 241.20. And dryers, they want you to do it, as a matter of fact. I thought we're talking about, okay, never mind.
Whatever.
Dryers, anything 241.20, guys, there will be a supposedly substantial amount of 120 load. At least based on the code. Okay. This is 0. You can argue here. Well, there might be some load that's, you know, connected we don't take 120. We take, never mind. Let's just go to add him up. Add neutral. Add. Which step did we have neutral? Hold on a second. 6, 7, sorry, and 8. Right? Give me the values for it, guys.
Why not
92.7.
Huh?
Oh, I said why not 9? I'm just because it's 0.
Because
Oh yeah.
One more time.
Never mind.
92.7.
92.7 plus
31.5,
31.5 plus 33 equal 157.2
KVA.
kVNA. So that's the value that will be carried. Step number 10. Okay. This is, I'm going to highlight this one for my beautiful neutral. My beautiful neutral. Remember that value, 157.2. Now here's where we're going to wake up. Anything that 240 we're going to drop. For fixed in place appliances, guys, anything 240 is going to drop. Water heater, for the most part, everything here is the only load that's 240 almost always as the water heater. So what we're going to do for neutral wise, the only thing that we need to take is these three values. So how are you guys going to do me a favor here? I'm going to erase this little thing, and next to it, I'm going to have the same thing, 6 times 30, and this one will be 5. Where 6 times 30, Chad, duh. There you go. This is drop. This one is going to be 1.6 times 30, the same way. This one will be 1.5 times 30, and this one will be 1.0 times 30. Do me a favor and add these. Add all these without the top one. Everybody knows why we dropped the top? 240.
123.
123. 120. Not 30, Chad. I think I'm getting hungry here, man. 123. kVA. Okay. Then you take the one, right? 123. Okay. Then you take the 123 and multiply it by what? 0.75. And what would that get you?
92 point.
How much?
92.
92 even?
1 times 0.75.
Because we still have more than 4 equipments connected to the neutral, the demand. Still the demand applies for it from 220.53 exactly like the phases. Is the answer 92 good?
Yeah, 92.25.
92.25, 92.3 kVNA. Okay? All right, that's it. So see how this step we can maneuver it a little bit. We drop the 240 from it. We just dropped the 240. Everybody knows why we dropped this. We dropped this. We dropped it when it comes to the neutral. And I'm going to say this is neutral. Neutral. And all of this is in neutral calculation. And neutral. Makes sense. Neutral. Okay. Let's go to the second step. So now we have 2 values. Remember, we had 1 value that we need to carry yet, right? For the neutral, derated, added, and we're going to have another value. Number 12, add 10 and 12. Can you guys give me 10 and 12 for neutral? 157.2 plus 92.3 equal
502.3.
5.
That's not right. Sorry, 249.5.
Yeah, 12 was the demand factor.
The demand factor. 1 point. Let's go back again.
Demand factor was 123 times 0.7.
92.3 plus the one before it was 157.2.
Oh, Oh, that was,
157.2. What's the answer? Gentlemen?
249.5.
249.5 kVNA. kVNA.
I have a question back on that, the one that we just did, you took it times 0.75.
Yep.
For the neutral.
Yep.
Let's see, we got. the demand-
220.53. Read through it.
That's the demand factor.
Yep. You add them up and multiply it by 0.723.
are you doing the cost?
Is 75. See, appliances in dwelling, it shall be permitted to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances
Yeah,
fastened
I
in
see
place.
that, but then that's what your neutral is gonna be then?
Yeah, well, for that particular load. We're doing the same calculation, guys. The same calculation, same demand, but for selected load that has 120. Same calculation, same demand for selected load that has 120. Okay, what's number 15? Number 14. Number 14 for motors. Okay, so we had our value already calculated here. Don't forget about that 249. We're gonna go to table number motors. For motors, guys, what do you expect? What do you expect to happen to the 240 motor? This one. What do you guys expect to this one? Drop it. So what are the two that has to be carried? This one and this one. And of course, I use the green here, so I'm going to use. The only thing I need to do now to calculate the neutral is took the largest motor, which one is the largest motor between the two? These two. One. So I'm going to take 1.25 times. What's the largest motor? 1.7 plus, don't forget that there's also 29 times 1.7. There's 29 left after I take the largest motor. Plus, what?
The 1 horsepower motor is the largest.
Oh, I'm sorry. Look to the top here. Okay, 1.9. So 1.9 times 1.25 times 9. This is just the format. 1.25 times 9. 1.9 plus 29 times 1.9. Are you guys with me? Plus 30 times 1.7.
Oh, because you
You took one out.
29.
What do you guys get? So this is going to be a neutral load. Anybody came up with an answer for Chad? Almost there. How much? 108.5. Anybody agree? Okay. Yeah.
Should we figure out the 29?
The 29, because there's 30 of them.
Yeah.
One of them will be the largest.
Oh yeah.
We took it up to the outside and we'll multiply by 1.25. The leftover from the 30 will be 29. Right? How do
You only get to use one.
one largest? If there is 30 motors the same size, you can only use one of them as the largest.
Oh okay.
Okay, so how am I going to say that this is going to be my calculation for the neutral with my mess here? I want to say this is neutral. Thanks God to the color, otherwise we're going to be in a big trouble. That's the only really things that you need to do in neutral. Okay. Anything about other loads for neutral? Well, there's nothing. So I'm going to go carry them. When you guys are ready, we're going to carry them to the next step. All right. Step number 15. I want to use black again. Can you guys give me, it was 149.5?
249.5.
I knew that one was put out. 249.5 plus what was the last one that we got? 108.5, and the answer would be 2, 3, 4, 358 kVA. We can tell it's getting closer to lunchtime, huh? 358. Hey, somebody's cheating here. Yeah, wait a minute until we. Okay, 358. 358, right? Everybody knows what we did? We just add them up. Okay, now let's go to the next step when you guys are ready. I added step number 13, 14, and 14.1, right? The same, what I like about this example, guys, we continue to with the same steps that we did for the phases, but we picked certain loads. It's really not a different calculation, same calculation. Okay? All right, now we're going to go to, we're going to do our calculation for the neutral. I'm going to go back to a different step, guys, for neutral calculation here. Neutral calculation. Okay, what was the value there? Again, 3. I neutral equal 358 divided by 240. What's the M? Don't forget the K. Thank you, because it's going to be balanced between two of them. We balance the load between the 120. Not all of this will be on 120. One will be on phase hot 1, the other one will be in hot 2.
So if we have 208, 120, we divide by 208.
You divide a single phase, you divide by 208. Yes, absolutely. So what would that be? 1491.6 amps. Okay. Now this one again, 1491.6. You take this one to 220.61 poly, the B, where we do it, 220.61B. It allows you another derating. It tells you if you take the first 200 amps, don't mess with them. The remainder, which is 149, 1.6 minus 200. The remainder, cut them by what? Was it 0.7? 0.7. This is coming from 220.61B. 220.61B2 to be accurate, and a 2 here.
So what does it seem between the parentheses?
It's here
1491.6.
1491.6 minus 200
Oh, okay.
multiplied by 0.7. Do you guys know how to do the brackets and all the stuff? Yeah. So you need to add these, right? You need to add them, to add the 200 to 0.7 of 1491.6 minus 200, add them all up. How much? 1104 point 1104. 1104. 1104. Huh?
Right here, the part B2, is that where the 200 is?
Yep, absolutely. You got it. Okay. The last step, guys, is the conductor. Conductor size. Conductor size. How many did I parallel? First, 11. So I need to parallel 11. 1104. 10. I'm sorry, 10. That will get me 110.4 amps. Take this one to 310.16 under 75 degrees. See what I'm doing? I'm paralleling them.
91 times.
Huh? Give me
Oh, yeah.
good size, but I have a problem though. Yeah, there you go. So give me number 2. If I do this one 10.4, guys, give me number 2. Except, can we parallel this than number 1 aught? So I have to cross this and go. My conductor will be 1 number 1 aught. Everybody knows why?
You have to leave that too.
You can't parallel?
Because you cannot parallel from 300.4 310.4. 310. I was close, huh? 10 off. 310.4. If you guys go to try it out. 310.4. That will get you. That cannot go lower than 1 aught. Okay, so we size our neutral. Everybody's happy with the size of our what was the size of our phase? 350. Now, is it wrong if you go pull 250 for neutral? You can pull 250 for neutral. Not a big deal. Now I want to do 2 things and let you guys go. We're going to size the grounding electrode conductor. Grounding electrode conductor. I hope that will, I'm going guys as fast / slow as I can. All right, everybody's there? Lunchtime, guys, come on. What's going on here? Okay, let's go. Now, grounding electrode conductor. Grounding electrode conductor, which is grounding electrode conductor. For this one, you go to 250.66 table. Table 250.66. Oh,
Step 16.
this is step, based on the steps that we actually have, that would be a step 20, grounding electrode conductor. That would be step 20 based on the steps that we have in the sheet. That would be step 20. Thank you. All right, what was the size of the conductors, guys, that we had? 350. How many of them do I have? 10. No, how many runs did I run? 10. Multiplied by 350 equal 3, 5, and 2 zeros. I know that one from the old days. KCM. Okay, you take the 3500 KCM, you take it to where? 250.66, and what size you come up with? 3 aught, right? Yes? No? 3 aught? Ollie, what did you do wrong? 3 aught. I have an issue.
Yeah, but if you did 350s.
3500 KCM. Because when you parallel, you multiply them by how many runs? 3 aught. Now we have a little issue. A little issue says, please write this down because it always messes the people up and it messes me up. It says, guys, the neutral conductor cannot be smaller than the equivalent grounding conductor. The neutral conductor. That's exactly what I'm going to go find for you. Where's my conductor? Somewhere where it says grounding in 240, where it says grounded conductor cannot be less than grounded conductor. Grounded conductor. High impedance. You're gonna take my word on it until I find the grounding conductor.
Grounding can't be smaller than neutral, or neutral can't be.
No, this neutral cannot be. And here's where, and I'll find you guys this one. Grounded grounded conductor must be equal or more than grounding electrode conductor. And the reason for this, because it's going to get the short circuit back into the service. I'll find you guys a reference. So based on this, then my neutral conductors are what now? Neutral conductors are 1, 3R based on this. And I'll find you the reference. Okay, so we sized
It is 250.
250, 22, 22C, 22. I don't see
I don't
C's.
have a 250/22C.
Are you sure
Oh,
it's
I'm sorry, 250, 24.
24C? 250, 24C, grounded conductor brought to the surface. Yes. The grounded conductor shall be installed, okay, through C, C1. Routing and sizing. Yep, thank you. So 220, 250, the article is 250.24.24C. What's the other one with C? C number 1. Can you guys highlight this one? Very, very important. C1. 250.24C1, routing. Yeah. All right, and also if you guys read it too, it tells you when you parallel them, you can't go less than number 1. Any question, guys? So let's recap what we have. See what just size our service. I have, then here's my service. Just to recap all the stuff that we've done. I have my service coming in here to the building. This service has how many sets did I say, guys?
So each
10
is gonna be what?
sets of 2 conductors. Each one of them is 350 kcm, and 1 conductor is, what's the other one? 3 aught AWG. That's the service. 10 sets of 2 conductor 350 and 1 conductor 3 aught, right? 1 neutral and the other 2 are what? The hots. And then from here, this is where the ground, from here, from here, where my conductor is coming, this conductor here,
I thought we used tiny conductors.
yeah, it's a 10 sets of 2 conductors and also 10 sets of 1 conductor. They're all in 1 conduit. And the electrode grounded conductor, or the grounding electrode conductor, grounding electrode conductor, what did we say? Yeah, right here. Right? So this is my service. And what's the size of my service? The size of my service? 3000 amp. What's the voltage? 240 volt slash 120. So this is the service. This is what you guys have sized. 3000 amp.
Your neutral can't be smaller than your ground.
Okay. Because you guys are so beautiful, I'm going to do one more thing, since this is really a good example, and then we're done. I'm going to size the bonding jumper. Here's the neutral, and we needed the service. We need to bond the neutral and the ground. This is called main bonding jumper. So, main bonding jumper, main bonding jumper. We're gonna go size this one based on 250.28, I believe.
Yes.
So you're gonna go to 250.28. What's the D1? Thank you. D1. And here's what it tells you guys. It tells you to go 10 times, what's the service? 350. That will get you 3500 kcm. Take the 3500 kcm, take it to table 250.66. Is it more from there? Is 3500K more than 1100K? Yes? If it's yes, is the situation yes, then here's what you need to do, right? 3500 is more than 1100. That's directly from 250.66, guys. Then, in a case like this, you need
Can we
to.
just take it times 10 because we have 10 sets?
Yep, absolutely. And actually, I wanna simplify it. I wanna say if 3500K is more than 1100K kcm, is it? The answer here is yes. Then here's what you do. You're going to take 12.5%, which is 0.125 times 3500K, and that's how you size your bonding jumper. If your answer is more than 1100 kcm, that's what you do. If it's less, equal or less, then you're going to go to where? 250.66. So what's the answer here? 437.5K.
I might do that wrong.
437. Two gentlemen, 437. Okay. Okay, then in a case like this, either you guys go to table. So I can't find a conductor like this, right? What do we need to do? You take the 437.5 either to 310.16 or chapter 9, table 8, and that will get you the next standard is what? Do we have 450? I don't think we have 450. You're going to go to the next standard, which is 500, right? So it's going to be one conductor, 500 kc and m. kc and m. So that conductor here, my friends, is 500 kc and m. How many of them? Only one. Just this is what is this Spencer is doing is taking the bar, the grounding bar in the panel, and the neutral bar in the panel, and tie them together with a piece of wire. If it's a switch gear, guys, they do that one directly bar to bar. They put cover bar, tie it. We don't even have to put a cable there. They tie them. They put bar to bar and bolt them together. So that's it. Now, exercise for you guys. I'm not going to do it. I want you to find me the conduit. Here's the exercise. I want you to find me the conduit. How many conduits do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the thing conduit that I installed for this system. And I'm not going to show, I'm going to show only each conduit is coming out of that, guys, a hot and 2 hots and a neutral. Typical. PVC. So size, yeah, I'm coming. Size for 2 conductors, 350 kcm. THW and 1 conductor. What was that, Fiat? AWG THW. You're going to size the conduit, and the conduit that we're going to size, we're using PVC schedule 80. Can you guys do this exercise? It's just size. How many conduits are we gonna end up? We know we're gonna end up with 10 of them. That's it. That's how many conduits we need to bring to this system. These are the conductors coming out of these systems, right? Okay. Is that cool or what? Practicing my artistic view here. All right, that's all. I hope that will explain it, guys. We will take a three-phase one. I don't think we're going to do it this time. We'll do it as we go, guys, through the whole year. And we'll take a three-phase example and we'll multiply it. So that's all I have for you. Go eat.
Yeah,